Hi guys, welcome to lesson 7.4, division properties of exponents. Our objective for today is that I can divide powers with the same base and that I can raise a quotient to a power. The essential understanding is that you can use repeated multiplication to simplify quotients of powers with the same base, expand the numerator and the denominator, and then divide out the common factors. So there is a rule that we can add in here. So our subtraction rule. So we have a to the m over a to the n is going to be equal to the a to the m minus n. All right, so if we highlight that, that is one of our rules. And there we go. All right, so that is our division rule. I have for letter A here written it out in expanded form. So there are 5 x's in the numerator and 2 x's in the denominator, x to the 5th, x squared. And I want to look at canceling out common factors. Well, that's a common factor. That's a common factor. Do I have any more common factors in my numerator or denominator? I do not. So now I just count up how many x's do I have. This is x to the 3rd power. There are 3 x's remaining. Now, if we go the subtraction route, we would have x to the 5 minus 2, which would be x to the 3rd power. Same thing. All right, now, how about letter B? We've got y to the 4th over y to the 7th. So we have 1, 2, 3, 4 y's in the numerator. We have 1, 2, 3, 4, 5, 6, 7 y's in our denominator. Again, let's cancel out our common factors. So we can cancel out that y, cancel out that y, cancel out that y, and cancel out that y. What do I have remaining in my numerator? Well, there's that coefficient of 1. So I have a 1 over how many y's do I have remaining? 3, y to the 3rd power. Now, if we were to use this, do this algebraically instead of expanding this out, it would be y to the 4th minus 7th, or y to the negative 3rd. And we know that if we have a negative exponent, Mr. Boland and Ms. Zirzo expect that we are going to rewrite it with a positive exponent. All right, now, what about letter C? Letter C is just starting to get a little weird. Now we've got 2 different variables in our numerators and denominators. Can we still do the same thing? And the answer is yes. So we have m with an extra loop, 2 m's. We have 1, 2, 3, 4 n's on top, m squared, n to the 4th, over m to the 5th. So 1, 2, 3, 4, 5, and 3 n's, 1, 2, 3. So now we're going to cancel out our common factors. So those 2 m's cancel, those 2 m's cancel. I'm left with no more m's to cancel. So now I've got 1 n, 2 n's, 3 n's canceled. So what am I left with? In the numerator, I have 1n, n to the 1st power. In my denominator, I have 3 m's, m to the 3rd power. Okay. Now, I know what you're saying. You don't like fractions, but you know what? Fractions are our friends, and we can work with these rational exponents as well. We can do the same thing, and now this is one that would be better off using algebra to solve for. So we have the same base, different exponents. So we have d to the 7/2 minus 3. We're going to subtract our exponents. Well, that is just 7/2 minus 3. 3 times 2 is 6, so we have 6/2 here. 7/2 minus 6/2 is 1/2. So d to the 1/2 power is the answer to letter D. All right, letter E. We've got a to the negative third, a to the fifth, b to the seventh, b to the b squared. So let's do this algebraically. So we have a to the negative third minus 5. I'm just taking the exponents as they're written. B to the seventh minus 2. Negative 3 minus 5, that would be a to the negative eighth. B to the seventh minus 2, b to the fifth. Are we done? No, because we have a negative exponent there. So we just move that down to the basement. B to the fifth over a to the eighth. Now, if you wanted to, you could have looked at that and said, well, I've got a to the negative third over a to the fifth. I could just bring that a down, and we've got a to the third times a to the fifth. You could do that as well. Okay, I want you guys to try these last four on your own, F, G, H, and I, and then I will go over the answers for them. So, y to the eighth over y squared. We've got y to the sixth power. 8 minus 2 is 6. Y to the 3/4 minus y to the 1/2. We've got y to the 3/4 minus 1/2. So we get y to the 1/4 power. Okay, letter H. K to the sixth over k, so we're going to subtract 6 minus 1. So we have k to the fifth power, k to the fifth power. And we have j squared over j to the fifth. Now, here's a little trick. If we're always going to be subtracting, and I know that that denominator has more j's than the numerator or whatever variable, I can subtract the numerator from the denominator. So we've got j down below, and it's 5 minus 2, which will be 3. Because I know if I write this in expanded form, I've got 1j, 2 j's in the numerator, 1, 2, 3, 4, 5. I know I'm going to end up with that j in the denominator because it already has more. And when you cancel them out, you get those two canceled, those two canceled. You're left with 3 j's in the denominator, just what I said there. Okay. Letter I. Well, let's take a look at it. We've got x to the fourth over x to the fourth. Well, that cancels out, right? 4 minus 4 is 0, and anything to the 0 power is 1. So x to the fourth and x to the fourth, those cancel out. Okay? So now we've got y to the negative first over y to the negative fifth. So we've got y to the negative first minus negative 5. And we have z to the eighth minus 1. So negative 1 minus negative 5. When we are subtracting a negative, it is the same as adding. So that's going to be y to the fourth power, z to the seventh power. So if we brought those 5 y's to the numerator, one of them is going to cancel out there, and you're left with 4 y's. Okay? All right, moving on to the second page. We have problem number 3, raising a quotient to a power. This is just like the power to a power rule. We are just going to apply the exponent to both the numerator and the denominator. So we have 3 squared over 4 squared, which we can reduce into 9 over 16. And as a fraction, that's not going to be reducible. All right, now what if we've just got variables? We've got b over c to the fourth. So we have b to the fourth over c to the fourth. And I guess I should probably write in our rule here. So the quotient rule is a over b to the n power is equal to a to the n over b to the n. All right, so that is our rule. Probably should have that written in there. Okay. Well, what if there's a negative exponent? What do we do there? Well, we could say it's x to the negative fourth over y to the negative fourth. Well, then we need to do some moving, and we're going to end up with y to the positive fourth on top. x to the positive fourth on the bottom, and there we go. You can do that all in the first step. When we have a negative exponent, we can just take the inverse of our fraction and make the exponent positive. Okay, so when we're dealing with raising a quotient to a power, if that power is a negative, we take the inverse of our fraction and we make the exponent positive. So we have another negative exponent, 2/3 to the negative third power. So we put 3 in the numerator to the third power over 2 in the denominator to the third power. And we just need to simplify. 3 cubed is 27. 2 cubed is 8. Okay. I want you guys to try letters E through H on your own, and I will go over them. So, x over 4 to the third power. We just distribute it. X to the third over 4 to the third, which, when we simplify, is x to the third over 64. 4 times 4 times 4. All right. 5 over y to the third power, so we're going to use that exponent to both the numerator and the denominator. So we're going to have 5 to the third power over y to the third power. 5 to the third power is just going to be 125 over y cubed. Okay. Letter G, we have x over y to the negative fourth power. So we flip our fraction. So we're going to have y over x. And we apply our exponent, 4 and 4. So y to the fourth over x to the fourth. Letter H, we have 4/5 to the negative third power. So we just flip that over. So we'll have 5 over 4. And we raise it to the positive power. So 5 cubed, again, was 125 over 4 cubed, which is 64. And we won't be able to reduce those fractions. All right. Last one, problem number 4, simplifying an exponential expression. We just need to now, we're dealing with product. So we're going to have to raise multiple things to the exponent. So we have 2x to the sixth over y to the fourth, the quantity raised to the third power. So that means that third needs to apply to each of the elements inside the parentheses. So we're going to have 2 to the third power, x to the 18th power, over y to the 12th power. Now, 2 to the third power, we know that is 8, x to the 18th, over y to the 12th. All right. Now, let's take a look at letter B. We have a negative 3. So the same thing, we're going to apply the same rule where we can just flip the fraction to its inverse and apply a positive exponent. So we're going to have 3 to the third power, y to the 6th power, over x to the 15th power. 3 cubed is 27, y to the 6th, over x to the 15th. Okay. I want you guys to try these final 2 questions, and then I will go over the answers. So for letter C, we are distributing the 5 to the numerator and to the denominator. So we have b to the 1/2 times 5 is 5/2 over 4 to the 5th, c to the 15th. So we multiply. 5 times 3 is 15. All right, now we just need to simplify that. So we have b to the 5/2 over 4 to the 5th is 1024, c to the 15th power. Okay, Last question, letter D. We have a negative exponent. So we're going to flip our fraction upside down. So we're going to have 6 to the third power x to the sixth power over 4 to the third power c to the 12th power. So 6 cubed is 216, x to the 6th, over 4 cubed is 64, c to the 12th. Well, I see two even numbers in our numerator and our denominator, and I'm pretty sure those can be canceled, or not canceled, reduced. So we always want to be looking to see if we can reduce our fractions. And in this case, we can. It's going to be 27x to the 6th over 8c to the 12th. Now, we won't expect you to simplify something that ugly quite on your own, but if you want to know strategies on actually doing that math and reducing that fraction, let me know and I can walk you through what you need to do there. Okay? All right. So last page is your usual reflection. Rate your level of understanding. 1, I'm totally lost. 4, I could teach this lesson. And write down any questions or confusions you may have. And then make sure you write a summary of what this process is in your own words. So how do we deal with division and quotients with our exponent rules? All right, that's all for today. Have a great night.